Hey guys, welcome back to AlgoYogi. We are doing two-pointers series. Next problem in the list is Backspace String Compare. Let's go to the problem on LeetCode, and the description is quite simple. So given two strings s and t, return true if they are equal when both are typed into empty text editor, and this pound key or hash key means a backspace character. Basically, you will go back one space back and whatever you typed just gets removed. It's just like, doing one backspace. So now note that after backspacing an empty text, the text will continue empty. Yeah, I mean, that's what we understood. First example is this, and we got to return true here because when we are typing it, so first in s and t we typed a and a here, and then we typed p, and then we typed in t d. However, they are not equal, but we know we pressed one backspace in both of them, so we're not comparing them, like right from the beginning. This problem can actually be really simply solved. So I just wrote down our first example here. So this is our example one. So this problem can actually be solved by using stack. It should be a stack problem, right? So but the problem is that stack will basically, it will be really easy to implement, but it's going to use big O of both of these. Like, let's say this is of n length and this is of m length. Then we're going to have memory, which is basically of big of n plus m. Since we will use that extra stack for both of these, and that will basically hold, basically it will add to this stack and this stack, it will add values. Like a will be added over here, and then it will add a for this, and then it will add, I should have changed the color, and then it will add b, and then it will add d for here. But then whenever it's seeing this pound key for both of them, then it's going to get rid of this b, right? And then it's going to get rid of this d for here, for this, and c it will add for this, and then it will add a for this one. Sorry, not a, c. And then finally we can just compare these remaining values in both of these stacks and just return true. But that's the problem, right? We're taking this, our time complexity will be big of n plus m, because, or it's like max of big of n and m, since we are just comparing both of them, right? Now the thing is, can we do better with space complexity? Yes, we can. And that's what our 2 pointers gonna help us with. First thing first, the iteration of these two will definitely get changed, because we really need to count these backspaces in order to remove the value that we have already typed. And there might be just a lot of backspaces. However, if they're if we have some number of strings typed and then we have some number of pounds, we need to go back, press that backspace and just get rid of those extra strings that are equal to number of the pound key. So now how about we just compare both string from the back, right? We start iterating. What I mean is we start iterating both of these from the back. So let me just do them further apart. Sorry. Yeah, take them further apart. Now I will have 2 pointers. One pointer, let's call it sidx, and then we have basically tidx. Okay, now these are the pointers pointing to the back of both of these strings. I will check if this is a valid string, then I will check if they are equal. What does it mean by valid string? It means I will have a helper function to check if this has been typed and there is no pound key before it. If there was a pound key before it, let's say there was a pound key over here, that means this cannot be a valid key to compare, because this is basically, it was typed by mistake and then it needs to go off, right? But if it is a valid key, then I have to compare it. Right now it's a valid key and they're equal, so I will just take my pointer and point it next, and I think this thing will just get ignored from, you know, both of these. But remember, in order to find a valid next valid character to compare, I will use my helper function, and that will basically keep track how many backspace it's seeing, so that it can ignore that number of strings next to it going this way. So it can ignore, because they were the strings that were typed by mistake, and now you're pressing the pound key to just get rid of them. And I think when we write the code, it will become like super straightforward to understand. Okay, I think then it's just that you keep finding that those valid index and keep comparing the strings. So here these two will be the valid index, and then these two will basically get, you know, they will be deleted, and then this will again be a valid index, and this two will be compare. And I think in this case it will return true, but I'm sure there will be a lot of examples where this will not be true. Okay, so let's write the solution. And this is efficient in terms of space complexity than if we were using stack. I think that would be a really simple solution also. Okay, so let's write down. First thing first, let's define this inner function, helper functions, to find the next valid index to compare, right? And since we'll be doing it for S and T both strings, so let's have it, you know, as a helper function to find out to reduce the, you know, this duplicacy of the instructions. Okay, so let's name it valid char, next valid char, or index. I think that will be better, because we will return the index from here. So, and then it will take a string that could be S and T, so that's why I'm having a string here, and then it's taking index, current index that it's pointing to. Now I will have a backspace count. I could just simply do it, write it count also, count, or whatever, you know, just let write it count. And then I'm gonna start if idx is basically greater than equals to 0. That means since we are moving from back to the front, you know, iterating it from the backward, so we have to check for the index, it's greater than equals to 0. Now if my string index is basically equals to the pound key, that means I increase my count. And if it is if my count, sorry, I didn't increase it, I just wrote the count. If my count is greater than 0, that means we basically ignore this idx and just and I think we're gonna decrement the index, and I think that we can do it outside because we will be doing for everything, but here we will actually use one of the counts. So let's reduce that. Okay, so we are using one of the counts, and else case I think we can break and return the idx, and I think we will, this is a common instruction, basically just decreasing the index. I could write it like in all of these cases, but keeping it outside, basically removing the redundancy of the algorithm. Let me just, you know, it doesn't look very nice, but I think I want to compact it so that I can write down, you know, the remaining part of the code. Okay, so now what we do is let's find out the index for S and T. So to iterate. So index s, or let's write it s index and t index, and we're gonna find it from length of s minus 1, so that it's a valid index. And we do the same thing, and we just do it for t. All right, so now we can start a while loop to basically check the valid index for both of these. Take that index, both valid index, and check if they are not equal or equal. If they're not equal, then we return false. Otherwise, we just keep processing, in the front, and until we just we have processed all the pounds key and all the characters of both of them, and then we just return true or false. So I think it's all about checking these two. So if s is basically greater than or equals to 0, I think we have to keep processing both of them, and that's why we'll have or. We could do and, but then again there might be a case where one of the string has been processed fully and the other one needs to be checked that it still has some string, and it still needs to go inside so that the other one doesn't have anything, it's empty, and this one has, so that it can return false. And I think only reason I am keeping it so that once I am done checking everything, I can return true in the at the end of the function. So if this is equal to or greater than 0 and t is equal to greater than, or t is equal to greater than, t index is greater than or equal to 0, that means I can keep going. So now let's find out this valid s index. So let's call it valid s idx, and that will basically come from over here, right? This is the function that we'll be calling, and sending in s and sending in basically this index, s index. Okay, so this will give us the valid index. It's not giving us the string, it's giving us the valid index. So valid s idx, I think that's better. Okay, and let's do the same thing for t. So we find out the valid t index for string t and for t idx, the original index that we are basically starting from the back. Now when we have these two valid indexes, then let's find out the character that they hold. But let's make a smart choice here, that if they were basically not in the bound, any of them were not in the bound, or it, like while trying to find out the valid index, it was just like it passed way past 0, it became -1 or something, then also we need to have like a empty string, and the other one will be either empty or not empty or whatsoever, and then we compare those. So char s will be basically s finding at valid s index if this is greater than or equals to 0, else we assign an empty string, and we do the same thing for basically t. So same thing for t, and then we check if char s is not equals to char t, then we return false. Then we gonna return false. Otherwise we just keep decrementing both of these. So I'm gonna just type both of them. Okay, and then I have a really bad habit of just copying even these small variables. I need to change that. It's not good. Okay, and I think that is it. We wrote a valid a helper function, next valid index, that takes this string, keeps track of how many pound key it has seen, and every time it sees a pound key, it increases the count. If it doesn't see it, then it decrements the count, so that we get rid of a character that was just before the pound key, and if we have any pound key. Otherwise, we don't have a pound key and we didn't see a pound key, then we break and then we return that valid index, and that's it. And I think this is just about iterating both of these, S and T, and just keep going and checking those valid indexes and then comparing the string they hold. If they don't, then assigning empty to them. Either they both ran out or one of them ran out, and we still have to compare that whatever ran out to tell that it was false. Okay, I think that's it. Let me zoom out and we can run our code on the example test cases. Just a little bit of some problem here. So it char s and char t. So these are not chat, these are char. Okay, sorry about those. So I think this will be okay. Typos. Okay, I think we have some issue, and that is a really minor problem here. It's not actually minor, but major minor whatsoever. It's just we were supposed to update them as well when we are finding these valid indexes, so that next time we are at a place where all these pound keys and these strings have been processed, and then you also decrement it by 1 over here. I think that will do the job. We are already zoomed out. Let me run it again, and I'm so sorry about that. These things happen. And valid s idx is not defined. What do you mean? Yes, of course, these are not defined, and we'll just change them. All right, and same thing happens over here. Same thing happens over here. So sorry. Part of the coding. Okay, now let's submit it. It's been very long video. Okay, awesome. 100%. Let's write the time complexity. That will be big of I would say that it's going to be big of so we have these two strings and we are basically processing the maximum of those. So it's going to be maximum of m or n, where m and n are the length of both of these. And for space complexity, if we were using stack, then it would be m plus n, but this time we are not doing anything. We're just playing around with the pointers and just iterating each string just at one time, right? Just one time. So it's going to be big of 1, and this is the entire code. Okay, so let me make sure you guys see it clearly. This is it. Yeah, looks nice. Let's go to AlgoYogi, mark this solved, and see you guys in the next problem. Until then, bye bye.